Most of the rocks here in the Southern Alps are calcareous, that's to say mainly made up of calcium carbonate. These vastly thick undersea deposits also produce marns, part clay, part chalk, rather than clays, none of which are refractory. Here you can see thin sandstone layers as well. Then about 70 million years ago, this piece of land slowly started to come out of the sea. And this black stuff you see behind me, called Brennan sands, is actually sand with lignite in, which is the result of all the plants that grew on this newly emerged land. A few yards down the road, and a few million years later during continental Eocene, the clays were washed out of those sands and deposited these multicolored, refractory but very sandy clays. Here's a roadside deposit of Eocene clay, similar to that from Brennell. But when tested, like many others, it melted. According to the geological map, there should be another outcrop of Eocene clay here, and in fact, in this abandoned pit, scraping the sides, one finds it. Also sand, very sandy, but I'll take a sample home to test. After testing these various clays, I came back for another look at Brennan. This is what I found under a roadside tree. A black clay with pale sand beside it, possibly the original Cretaceous clay. The results will come to later, but dig much more here and the tree will come down, but at least we know that it does exist, hopefully in greater quantity and better placed, so back to the geological map. Well, the geological map showed more deposits of Brennan sand and resulting Eocene clay down this way. That black clay from under the tree fired at 1300 degrees centigrade to a pale oatmeal, with apparently no problems to begin with. If I do find what I'm looking for, it will have to come out on my back. I wonder how many friends with large, empty rucksacks I could lure down here. Having passed through the middle Cretaceous landscape typical of this area, I come to a richer land, showing red, sometimes black sands with a little clay. This would be Eocene clay again, but this time much less sandy. Further down across the stream I can see white sandhills through the trees. Closer, and here are fossil sticks embedded. Then I find the lignite itself. And beside it, at last, a sizable deposit of black clay, right beside the lignite. Fairly sure of myself, I'll take a good sized sample. If you find a clay you think is worth testing, just bring a small sample home, a kilo or so. Pummel it about a bit until you get into some kind of plasticity. Shrinkage is plastic to dry. Make two small bars, about 11 or 12 centimeters long, and we mark exactly 10 centimeters on each one. And with the code CV for the place I found it, 107. Mark that down in a notebook and leave them to dry, and when you read it off, we'll find each millimeter will be 1% of shrinkage. And a few days later, when our little sample is dry, we can then read off that there's been 8% shrinkage. This brings us to the end of part 1. Part 2 is about glazed materials and natural grogs. But as you see, I did get a few sporting friends to help haul the clay out.